In this lesson, we're going to take a look at parent functions. Here is a list of all of the parent functions that you should be familiar with. The first two we're not really going to focus on. You should be very familiar with them from Algebra 1. The first one is y equals x, or f of x equals x. That's a line straight through the origin with a slope of 1. The second one is a constant function, where you have y equals some number, like y equals 4. That would be a horizontal line. The rest of them, you should have an idea of what they look like, and it might not be a bad idea in this slide to sketch what each of these functions look like, so you have that mental picture when you see the function, what it should look like when you're graphing it. So hopefully parabola you're familiar with, the U shape, cubic, I've heard students call it the snake. The square root is half a sideways parabola. Absolute value is the V. The inverse and inverse square I'm going to sketch for you. So the inverse is a hyperbola. It has asymptotes along the x and the y axis. Of course, that domain restriction would be not being able to divide by 0, so x cannot equal 0. Inverse square has the same domain restriction, x is in the denominator. This one, however, because of the square, I've heard students call it the volcano. It also has asymptotes along the x and the y-axis, but it's entirely above the x-axis. And finally, the last one is the step function, and that's the one we're going to focus on because it's probably one you've never seen before. Another term for this function is the greatest integer function, which I wouldn't recommend focusing on that. It's a little bit backwards to what's actually happening with this. And another way to think of it is the rounding down function. So let's start by generating some t-table values for our step function. Now each input into this function, you round down to the greatest integer less than or equal to that value. So instead of thinking greatest integer, think round down to the nearest integer. You are always rounding down, not rounding in general. So let's start taking a look at the first few t-table values, and hopefully you understand what I mean by not always rounding to the nearest value. Negative 3 is an integer. Anytime you put an integer into the function, you get the same value out. Negative 2.5, when you round down, negatives work backwards than positives, so negative 3 is the greatest integer, smaller than negative 2.5. Negative 2.1, again, we are rounding down, not rounding to the nearest integer. So when we round negative 2.1 down, it goes down to negative 3. Negative 1.5 would round down to negative 2. Negative 1 is an integer, so we would get our same value out. Negative 1/2 rounds down to negative 1. 0 is an integer. Half rounds down to 0. 9/10 rounds down to 0. 1 is an integer, and so on. If you have any questions on where I'm getting these values from, absolutely, we will talk about those on Monday. What you should do now is grab your assignment for Monday, the 1.5 Day 1 assignment. This is question 7 on your assignment. So pause the video while you grab that. And I will start to graph the function for you so you can have an idea of what it looks like and why it's called a step function. And this is going to be your you try problem to finish this up as much as you can, and we'll finish talking about this graph and everything you need to know about it in class. So we'll start, we've already got a t-table of values on the previous page, so I'm not going to fill that out. I'm going to start by plotting some of these points. So the first points I'm going to plot are this group right here, the ones that are rounding down to negative 3. I'm going to call each of these scaling by 1. And when we substituted negative 3, we got negative 3 out. Negative 2.5 rounded down to negative 3. Negative 2.1 did as well. And thinking about what the graph looks like so far, what happens is that we've got an open circle at negative 2 because anything just slightly smaller than negative 2 will round down. But negative 2, of course, will give us a value of negative 2. So we have a line or a step along that integer distance. -2, however, would round to -2, or stay at -2. -1.5 would round down, -1.9, -1.1. Everything between -1 and -2 would round down to -2. Similarly, between 0 and -1, everything would round down to -1, and so on. So I'm going to let you finish coming up with what that graph will look like. See if you can come up with a domain and range. This one's going to be a little bit tricky to think about. The intercepts as well will be a little bit challenging. There's no critical point on this graph, so you can cross that part off. And like I said, we already generated a t-table, so you don't really need to do that part either. So try and finish up the graph, so you can come up with a domain and range and intercepts, and we'll discuss the rest of this graph in class.